So in number 54, we have a 100-volt battery, a couple of resistors, and a 2 Henry inductor. Immediately after the switch is closed, what are I1 and I2? So a couple quick reminders about inductors. Inductors always oppose the change in current. So initially there's no current in this inductor, and so when you first close the switch on this, it's going to try to prevent any current going through it, and so there will be no current going through it. It'll act like an open circuit. So solving this first part, just using Ohm's law, what do we have here? Well, we just have the current going around this portion of the circuit. So the total resistance just has the 10 and 20 ohm resistors in series. It's just going to be 30 ohms. The voltage is 100. There will be no current at all flowing through this section of the circuit. And so the current through I1 up on top here is going to be 3.33 amps. And that's also going to be the current then through I2. But now things get a little bit more interesting. Now for this okay. A long time later, what are I2 or I1 and I2? Well, a long time later, this inductor is going to be acting like a wire again. And now the current is going to come out of here, and it's going to go both this way, and part of it's going to go this way. And so we've got a little bit more interesting situation. Solving this one, first of all, we got to figure out what is the total resistance of this section. I can remember the inductor at this point is acting like a wire. So we just have the 30 and 20 ohm resistors in parallel. And if you solve that real quick, you'll discover the total resistance of these two in parallel is 12 ohms. So now we can actually answer what I1 is. Again, using Ohm's law, 100 volts. And now the total resistance of this circuit, you've got this 10 ohm here in series with this overall section over here, which is 12 ohms. Total resistance now is 22 ohms. And if you solve it, you'll get 4.55 amps. But now the question is, what's the current through I2? Well, if you look at it closely, we can do a little bit of the same tricks we've done before with Kirchhoff's. The voltage drop across this 10 ohm resistor is going to be the current through it, 4.55 amps, times its resistance, 10. So it's going to be a 45.5 volt drop. If we start with 100, that'll leave us at 54.5 volts at this little blue circle junction. We know the voltage down here is going to be 0, and so we can very quickly then figure out what the current through I2 is going to be. What's going to happen here? Well, we can just use Ohm's law on this one. Voltage is going to be that 54.5 or 100 minus the voltage drop over 20, and that gives us our current. Now, I'm going to do an extra step here, which, trust me, will come in handy a little bit later. I want to know how much current is actually going through the other branch of this circuit, going over here for the 30 ohm and then through the inductor. If we do that, we'll end up with a very similar equation. Sorry, it's slightly cut off here, I just realized. We'll discover the current through this other edge, through the 30 ohm resistor and the inductor, is going to be 1.82 amps. Resistance down here, if you can't quite see it, is 30. Trust me on this one later. Because our next question is, the switch is then reopened. Just then, what are I2 and I1? So, if the switch is open, what happens? Well, if the switch is open now, no more current flowing from the battery. There'll be no current flowing through here. But what will happen is there was a current going through this inductor. And remember that inductors always try to maintain the current all the time. So in this case, it's going to be that same 1.82 amps that we calculated a moment ago. But there's no current at all that's going to be flowing through this 10 ohm resistor, so that's 0. What's the current going through I2? Well, it's going to be that entire 1.82 amps that the inductor is going to try keep going around the circuit. And yes, you could even calculate the voltage it's going to need to generate to do that. Why negative? Because they drew the current this way as being a positive direction, this inductor is going to force current around it in the clockwise direction, which is against that current, and so negative. And then finally, A long time later, what are I1 and I2? Well, this inductor can't keep current flowing forever. So after a very long time after the battery is disconnected, this current is going to dissipate exponentially and eventually become zero. And so our final two answers, what are I1 and I2 after a long time? Well, I1 is still going to be zero. And then I2 will eventually reach zero after a very long time. Yes, this question had a huge number of questions or points to it, but hopefully it made sense. Good luck.